Hi everyone, Mrs. Below here. In this video I'm going to be going over percent yield. So percent yield is something that you have to calculate using this equation here, and it's the actual yield divided by the theoretical yield times 100. Well, what is the actual and theoretical yield? So the actual yield, this is the actual amount of product that was made in a lab setting. So this is the actual amount or what was measured in a lab setting. And the theoretical is the max possible amount of product that could have been made, given a certain amount of reactant or reactants used in that experiment, in that chemical reaction. Now, everything we've been talking about up until this point, all these picket fences, all of this math, that has all been theoretical. That is in a perfect conditions, in a perfect world, in the perfect lab setting, that's the most amount of product that we could make. But what actually is made in a lab setting might be different. And so obviously if you get 100% yield, that's great. That means you made all of the product that you could have possibly made. But that usually doesn't always happen, doing things in practice. So if you get close to 100%, like 99%, 98%, that's still really good because you're still getting pretty close to the maximum amount possible of product you could have made. So in order to calculate percent yield, how much product did you make out of 100% that was possible, we need the actual and theoretical yield. So the actual yield in a problem is something I would provide to you. That's information I have to tell you. So in this equation here, what I have highlighted in yellow, this of course is the product. There's two products, but in this problem I'm specifying what product you're focusing on. So that might happen. There might be multiple products for you to pick from. Focus on the one that is specified in the problem. So CaO, so calcium oxide, this is the product we're focusing on for this problem. And I say in the question, what is the percent yield of this reaction if we had this much of CaCO3 and we heated up and we got 13.1 grams of CaO. So the actual yield is 13.1 grams of CaO, calcium oxide, because I have to tell you that information, and that is one of the products, as you can see in the equation here. So that has to be the actual yield. I have to tell you how much was actually made. So then we have to calculate the theoretical yield by doing a picket fence. And in this problem, you can assume that the reactant, that in this case we only have one reactant. If there are multiple, you can assume the reactant I'm giving you is the limiting reactant. If I did give you two reactants, then you would have to figure out the limiting reactant first using what we learned up here. And then you can use that value to get your theoretical yield. So in this problem, I'm only giving you one reactant. So you could assume that's obviously going to be the limiting reactant. There is only one. And we need to convert that, the 24.8 grams of CaCO3, we need to convert that into grams of CaO, because then that's going to be our theoretical yield. So then we can compare these values to each other. This is a value I'm giving you. That's what actually happened. In order to find the theoretical, what was the maximum possible amount of product that could be made, we have to do a picket fence to convert the reactant that was provided in the question into the product that we're focusing on. So this will be a grams to grams picket fence. So we're taking the reactant, 24.8 grams of CaCO3, and we're going to convert that into grams of CaO. And this will be then our theoretical yield, and then we'll plug that into this equation to find the percent yield. So if this is a grams to grams picket fence, we have to first start with grams of CaCO3 here in the bottom. Well, if that's grams, then that means I have to find molar mass. So let me see, calcium 40.078. So I'm going to just write that right here, the molar mass. So 40.078, that's calcium plus carbon, plus we have 3 oxygens, and that is 100.086 grams of CaCO3. So that's molar mass, which I calculate using the periodic table, and that's always equal to the thing that goes above it, which is 1 mole of CaCO3. So all I've done is convert grams into moles. Now that I have moles, I can use the balanced equation, which they all happen to be a 1, which is kind of nice. So in the bottom here, I have moles of CaCO3 according to the balanced chemical equation. That is 1 mole of CaCO3. And then again, I'm trying to convert it into the product that I'm focusing on in this problem, which is CaO, and we have 1 mole of CaO according to the balanced equation. So now I've converted moles of CaCO3 into moles of CaO. And now for our last step, we have to find grams of CaO, calcium oxide. So I know moles of CaO has to go here, and that's going to be 1, and that's coming from molar mass. And above that, I'm going to put the grams of CaO, which is molar mass, so 40.078 plus 15.999. So 40.078 plus 15.999, and that is 56.077. And now I've converted moles of CaO into grams of CaO. So that was moles to grams. And then I'm going to go ahead and calculate this. I'm going to multiply everything in the top. So 56.077 times 1 times 1 times 24.8, and then divide it by the bottom, which is just 100.086 times 1, which is still 100.086. And so that's going to give me 13 we'll go 4 sig figs, so 90 grams of CaO. So that is the theoretical yield. So I'm not done yet. I still have to do percent yield, which is the actual 13.1 divided by the theoretical times 100. So 13.1 divided by 13.9 times 100. So that'd be 94.24%. So that's not bad. So 94% of the product that could have been made was actually made. All right, let's do one more example. So in this problem, I have 2 products and I have 2 reactants. But again, in this problem, when we're looking for the actual yield, again, that is going to be the product, which in this case, we're focusing on copper. That's the product. So it looks like there was 14.65 grams of copper that was actually made or produced. And it looks like our limiting reactant that we're going to be using is aluminum. So we had 1.87 grams of aluminum. So we're going to take that 1.87 grams of aluminum, which is the reactant, and we're going to convert that into grams of copper, and then that will be our theoretical yield. So I have 1.87 grams of aluminum. This is one of the reactants. I know it's a reactant because it's on the left-hand side of the equation here. You can assume that's the limiting reactant. And now I'm going to convert that into the product, which we're focusing on is copper. And I already provided the actual yield of copper. So we're doing this picket fence to find the theoretical yield of copper. So in the bottom here, I know this has to be grams of aluminum, which we need molar mass for that. So 26.982. We don't have to do any calculations because it's just aluminum, so I just have to look on the periodic table for that number. And then that's equal to the thing that goes above it, 1 mole of aluminum. All I've done is convert grams into moles. I know moles of aluminum have to go here in the bottom, and this is when I use the balanced chemical equation. So there's a 2 here, so I'm going to put 2 moles of aluminum in the bottom. And then again, the thing I'm trying to convert this into is copper. That's the product that I'm interested in. And according to this balanced equation, that is 3 moles of copper. So I've converted moles of aluminum into moles of copper. And now I have to convert into grams of copper. So to do that, I need molar mass. So again, molar mass is always equal to 1 mole. So I'm going to put 1 mole on the bottom. And then above that has to be the grams of copper, which according to the periodic table, 63.546. 63.546 for copper. And now I've converted moles of copper into grams of copper. So this is now going to be my theoretical yield. So I have to multiply everything in the top. So 1.87 times 1 times 3 times 63.546. And then I'm going to divide it by the two things multiplied together in the bottom, which is, so divide by 26.982 times 2, and make sure you just do your order of operations correctly. So this would be 6.606 grams of copper. So that is my theoretical yield. So now to find the percent yield, I have to do the actual, which was 4.65, divided by the theoretical, which I got from the picket fence, 6.606. And then we multiply that by 100. So 4.65 divided by 6.606. And then we're going to multiply that by 100 to get it as a percent. So this one's a little less than the previous one, so 70.39%. And that would be my percent yield. So again, if I give you a product in the problem, that means that's your actual yield because that's the actual amount of product that was made. The other value is one of the reactants. You can assume it is the limiting reactant in the problem. You're going to start your picket fence with that reactant, convert it into the product, grams of that product, and that will be your theoretical yield.